All right. Welcome to Upstreaming 201. You're now all experts from your experience of reading slides along with me in 101. So we've had Upstreaming 101 for years here. My predecessor, Deepak Saxena, he had suggested when I took this over that we should add this next one, and it's kind of fun because we look at real examples, mailing list postings, which are kind of a pain to format and put on here, but it's definitely worthwhile to see real series and so forth. So we'll jump into that, and I also hope you read some documentation too. So we build on Upstreaming 101, example driven, like I said. We'll look at subjects and commits messages from real postings and people responding to comments, and we'll look at an example of upstreaming a new platform, right? A new ARM-SoC. See how that looks, and then another, a very simple example, also a very simple example upstreaming a new driver. I consider this, even though we're in this huge barn of a room, the training format, I mean, I'd be more than happy if you just interrupt me at any point and ask a question on the slide. It's a lot easier that way. I truly would have preferred one of those little cozy rooms that we could have a chat, but I can never convince them to give me that. Okay, so first off, let's talk a little detail about the ARM-SoC tree. It's pretty important to everybody's work. At Linaro, you end up touching the ARM-SoC tree not only when you're doing a platform enablement and upstreaming, but also when you're touching a driver that has a DTS component, or you need to update the DTS in your platform, which happens a lot. So the ARM-SoC maintainers are very, very busy, and I keep saying this about maintainers. They're very, very busy. They kind of have a thankless job. There's a lot of stuff that goes through this ARM-SoC tree. And they have some requirements on how things should be submitted and sent to them. Normally people will say, well, this only really applies to machine platform maintainers. I've previously done that for the Broadcom mobile parts, and it's pretty important when people are sending the sub-maintainer, the sub-arch maintainer is sending patches in a pull request to the ARM-SoC team, but you can make your platform maintainer's job easy by actually understanding how they have to have things divided up, because if your patches aren't divided up properly, they're going to ask you to redo it, right? And that causes them heartache. So with that said, what do I mean by this? Well, ARM-SoC team, if you have fixes to something in, say, your mock directory, right? For us, it was mock BCM for the Broadcom stuff, right? Mock OMAP 2. If you have a clear bug fix, you need to have that in a separate commit. Right? We talked about having fixes in separate commit. What you can see on here is they have a fixes category. They have a separate topic branch for that. If you're doing cleanup code, people have come in and cleaned up, say, the L2 cache code, enablement code, and they touch all these different things. Those things go on a cleanup branch. So say you were going to contribute something like that. SOC code, which are things that are, say, new functionality in your, say, mock BCM or whatever your SOC is, those go in next SOC. Sometimes there's dependencies where you want to keep from breaking bisectability in the kernel, and the ARM-SoC team can take drivers in with agreement of the driver maintainer or the subsystem maintainer through the ARM-SoC tree. In that case, the driver would, again, have to be a separate commit, and it would go through here. And then boards are for legacy board file ports, which are almost all on the way out. And then any DTS file changes are here. So what this means is, if you got a driver, yes.
Are these topic branches on their tree? Is that?
These are topic branches in the arm-soc next branch that gets pulled into next, and then
Yeah. Okay.
Yep. And so the key is, let's take the driver example. Okay, you got a new driver, and we'll get into a real example of that. But you can't have a DTS file change for your platform sitting in the same patch as the actual driver. They have to be in separate patches because the DTS goes through the arm-soc tree, right? And the driver goes through the subsystem maintainer's tree. So if you wrote a regulator driver, right, and there's DTS component that you need to enable, 2 different patches, they go to separate maintainers in one series, right? But the series is a logical set of changes, right? To get together as a whole, it enables that regulator, right? That PMIC and that on a particular platform. So that's why you want to be aware of this in the arm-soc stuff. Like I said, usually the platform maintainer worries about this the most, but you can make their job easier by just being aware of this. Olaf Johannesson, who's one of the arm-soc maintainer team, did a presentation back at ELC 2013 that explains this in greater detail. So you can look at that link and take a look at his slides on the details there. All right. Now, this is where because if you really digested what I said in 101, I answered these questions over and over and over for my Broadcom landing team when I was mentoring people doing this, because they just didn't seem to read the documentation or forget that it's there. So when we talked about subject lines, they have exact steps in here of what the summary message portion of that subject line should be, right? I mean, 70 to 75 characters. It's very specific, right? So all the answers are really in submitting patches. If somebody complained about something, you just say, hey, I did it exactly like it says in submitting patches. It's a well-maintained, this is not stale documentation like your average wiki. So to show that's exactly where this format of the patch tag and the summary phrase comes from. All the information on how to revision things, RFC to indicate a request for comments, right? So it's all in there if you forget any of that, or the why, or you need a little bit more detail. And they even show you how to do the numbering for the multi-part series. So that's right out of submitting patches. All right, so commits. Really talked a lot in the first one about good commit log messages. And this is the why. They're actually telling you why, right? So your commit log message will live forever in the kernel code. And what I like about this explanation is it makes you think about what happens when somebody comes along in 2 years and wants to break your thing. They don't want to, right? But if you have a vague description and don't explain why something's needed or some subtle reason why it could break, I did it this way because it will break if we, don't have this particular piece of code. You need that for that person coming along 2 years later or 1 year later, or the person who doesn't know the context. That's why you need to have that in there. That's the only way to keep things running, is to have a full explanation in there. So don't be terse. You need to be concise, have the full amount of information that somebody who doesn't know the immediate stuff can at least understand why something was done so they don't break it. All right. So be descriptive, as it says. Yeah, I like how since commit messages are important, there was this gentleman had this explanation in a patch, right? That we want to calculate the blinks per second, and he sort of tries to explain it, but it doesn't really explain why, right? Instead of making it 5, let's make it 4. And it's not entirely clear. So if you saw that a year from now, somebody, they're like, why did he do that? I don't understand. There's not enough information there, right? You can kind of see that there's a problem. So Ingo makes it very clear, right? And it's kind of captures that what, why, and how, right? Current code does A. This has a problem in B. We can improve it doing C because D, right? You have to think that way, what, why, how, or the way he has that. And this log up here doesn't make that clear at all. So definitely, we tend to, as engineers, understand it ourselves, but one of the best things can be, can you explain it to somebody else, a colleague or something? Use that explanation. If you explained it to somebody else and they understand it, use that to put in your commit log, right? All right, so example of a good summary or commit message, going back to that documentation. What we see on the subject line, we see a bracket patch, right? And then we see the subsystem. And here's a subtle little thing. In the generic format, we showed just, oh, here's the subsystem and a colon and the summary phrase, right? Well, here's an example where it goes multi-tier, right? So it's an ARM patch, but it also is a DTS patch. So that goes in Arch ARM, all right, boot DTS. And then it applies to that particular DTS file and then the summary phrase. So that's good. It's very specific, right? What's nice about this commit message, taking a very simple case, is that he's very clear that when he makes this DTS change, that both of those SDHC controllers are 8-bit wide. So pass the bus width property to reflect that. And he tells you what happens if you don't, right? If otherwise, it's going to operate in the default mode. And we don't want that, right? Probably because it's got a Wi-Fi on it. Okay, so that's a great example there, simple one. Incorporating comments. We think about, when I was saying about don't ignore comments, right? Don't, if you don't understand something, right, get it clarified. One great way to signify that you understand and you're going to address a comment in the next version is just reply inline, right? We always reply inline, we never top post. Probably should have added that to this. But, you know, there's a comment here, and basically the comment is to capitalize those, right? Those acronyms, and just say we'll fix. Yeah, that signifies, that way they can expect to see that addressed in V2, right? Clarifying comments, right? I said ask questions. This is a great example of, it's very, if you're not familiar with DT bindings, you're new to it, you probably have a lot of questions. This is an example of a person where some of the subtleties of the binding may not be readily apparent. And the maintainer has sort of a vague explanation, right? The specific value of this shouldn't matter. What should matter is what it logically corresponds to. Maybe not perfectly clear, right? So in this case, this submitter says, hey, you know, I'm not quite following this. Do you mean this or this? Ask the question. He got a response. I don't show it here, but you know, they will answer and clarify, you know. And then ignoring comments, the big one. So, in fact, I pick on Mark Brown because he's the one that told me to add this in last time. So, so I'll use his example. Here's a series where he's in V2. He made a comment in V1, and in V2, it got dropped again, and Mark had to take the time to go paste his comment from the original version back in and remind him, and actually had to remind him like 3 times throughout this post, because it just totally ignored the comment, didn't incorporate it, was silent on it, and that'll upset anybody, right, when they're spending their time reviewing your code. And here's an example nobody that's a professional should ever do. In a long thread about putting Allwinner SoCs upstream and somebody disagreeing that that DT will work for it, he launched a personal attack on this particular developer, so forth. And this is a great way to get ignored forever and have, especially when you're saying this to a respected kernel developer, pretty much everybody will start ignoring you at that point. So shouldn't be a problem for anybody doing this professionally, but great example that people can get very upset, and it's just not appropriate to take it to that level. All right, so let's look at an example of upstreaming a new platform, how we would divide things up, right? That's always a question. So let's say I had a new SoC, we will call it foo, okay? And so I'll have to have this new directory, mock-foo, and in that there'll be some ops that are specific to this family. Well, those will go to the ARM SoC team. And we think back to that, how you divide up the categories. It would be in the next SoC branch is how they would bring that in, okay? But then you also need a clock source driver, right? Got to have a timer tick. So that would go to another set of maintainers, right? And then if you're not using GIC, you probably, maybe you've got your own IRQ controller. Well, you need to write a driver for that. And that would go to Thomas Gleitzner. And then you're going to have a platform. Device tree binding. Okay, that gets sent to the DT team, and then you may have a def config. Maybe you need to modify the multi-v7 def config. That also goes ARM SoC team, and then the DTS. But those things go on different branches. So you can't put the multi-v7 def config change or maybe your new def config in the same patch as the DTS file. They have to go on those separate branches. That's why you want to be aware of those categories for the ARM SoC team. They're all separate logical changes. Yes?
So is the device tree separate thing explicitly documented somewhere? Because last week there was some confusion for the new high silicon SoC. A respected kernel developer said you should squash the patches. They submitted it, and then another developer said you should separate them.
It's gone back and forth, and it got clarified the last time around is they've got to be separate.
Okay.
They want to review them separately. So the final word on that is in documentation device tree bindings as far as the bindings, right? And the DTS stuff has to be separate. It goes through a separate category in that tree. The only thing that can go on that next DT branch are those DTS changes. So if it's a DTS file, right? The binding and the DTS part are two separate entities. So this logical split is it's divided amongst maintainer trees for one in this, right? It's divided by drivers, right? And it's split also according to the ARM SoC categories. So there's a lot to consider there. So let's look at an actual one. This is when the first Allwinner A1X A10 parts went upstream. Maxime, it's a good example of a cover letter. We talked about multi-part series and cover letters. He takes the time to explain why he made the architecture name a certain name, right? It covers both Sun 4i and Sun 5i, so he explains his rationale for calling it Sun Xi. And then he talks about what it runs on, and what's really nice is in the cover letter, something that doesn't need to be in the permanent change log. None of the cover letter goes in there, but he takes the time to say, hey, this is just the beginning. We boot to init RAM FS. It's like any bring up. Your first thing is to get there and have a UART, right? And or not, or no UART, and eventually we'll get the other stuff. So he gives the maintainers an idea of what the roadmap is in there, since it's very basic. And Thomas gives him some suggestions, some comments. And Maxime, in this case, you don't always have to say, oh yeah, I'll address that or whatever. He quickly follows up. I think it was a few hours later, and he sends a V2. And this is what we discussed about change, a cover letter change log. This is a great example of, he only had to adjust that one patch, right? Well, actually there were several other comments, so there was multiple changes in there, but he, in the cover letter, shows us that changes from V1. You'll see that pattern. It helps people to see overall that these comments were incorporated, what are the major changes, right? Because you've lost that diff history, so it's just captured in here that the changes were incorporated. So that's great practice. This all happened very quickly. It was in pretty good shape, and so Arndt Bergman accepted the patch, and he spent some time clarifying how Arndt would like to have the patch taken. Either they could take it directly or a git pull request, and so he clarifies that that'd be preferred. So always good to ask the questions. And then Maxime follows up with a pull request as requested, right? So Arndt says, hey, it's a bit more work for us to take a patch. We really want for the new platform or platform updates that you just send us a pull request. So there he does. In Git, there's a command to send a pull request. Most maintainers will take individual patches and apply for you for most of the work, but if you're doing a new SOC platform, they'll be wanting you to maintain that and do pull requests. So that's what it looks like. All right, so let's look at an example of a really simple driver, because watchdog drivers are about as simple as they come. So if we're doing a watchdog driver, and a lot of this is I would show the DT stuff, and some platforms, if you're an ARM platform with ACPI, obviously that would be different, but it's a pretty good example. You're going to have a device tree binding, and that would go to the DT team, and Vim, who's the watchdog subsystem maintainer. They have joint review ownership over bindings. And then if there was any watchdog framework changes you need to make, that would go to that subsystem maintainer. Driver and build plumbing, def config update. We see that same trend, right? The mock maintainer, on Broadcom we had our own BCM def config. So if a change needed to be there to enable that watchdog, that would go to the mock BCM maintainer, so that's separate. The DTS file, right, is existing platform where we're adding a driver. That DTS addition would go through that platform maintainer, not directly to the ARM SOC team, but to that platform maintainer, right? It would be part of some platform's DTS file. So again, we're split amongst the maintainer trees that own each of these logical changes, right? So you would never have a patch or a commit that would go to two separate maintainers. It's got to go into one tree, right? So you got to think logically to divide that way, and then it's split to divide amongst framework updates, right? I need an API change maybe in the watchdog tree, specific driver features of the new driver, and then individual bug fixes. So dividing all that out. So let's look at creating a driver series. If you committed code in this way and you had things divided up, this is a real example of somebody on my old team that did a watchdog driver, and he already had a DT binding upstream because it was used for the reset at the platform level. And so if we just look at the one-line git log, the turf summary, we see it was divided up. The driver was one commit, and then enablement on the def config was in this other commit, and that was tagged to go ARM BCM 28A1XX to go through that mock tree. If we didn't have the other pieces upstream already, it would have looked something like this, where you have the binding, you have the driver, you had the def config change, and then a change to the DTS file, right? So that's what it would look like in Git if you did a log on that. Oops. All right, so if we want to create patches that look like that, we showed that commit log, and we'll take the simple case. We had those other pieces upstream. We want it to look like this, where patch 02, and that's our cover letter, and we want 102 to be the driver and 202 out of those commits that we showed in the Git log, right? So exact steps, you can do something like this. There's a lot of different ways to do this, or script this, or flows to do. Here's just a really terse basic thing. You run git format patch. If you give it the cover letter option, then it will generate a template of the cover letter with a diff stat for the whole series and everything in there. So it does all that. You put it into a directory that way. You tell it what hashes to range from in the git range format, all documented in the help. And so your results in that directory look like this. So you get a set of files like that. Those are ready to send out to the lists. Okay. Well, the cover letter, you have to fill in your novel of what this thing is. So knowing that, we look at what Marcus did here. He had the cover letter, has it properly tagged as subsystem and the summary phrase. It's a simple thing, so you just don't need a whole lot of explanation for a watchdog driver. Series implements introduces this watchdog driver for this family. So he pretty much covers everything you need. You can see everything when you run cover letter, right, and you're using format patch, you get everything but that explanation up on the line. So it will dump out, do the diff stat, have the subject line, which or just part of it, and then you can fill out proper subject line and that explanation there. So that's what a well-formed cover letter looks like. All right, so when he posted this is what the watchdog driver post looks like. Again, he had this reviewed ahead of time by myself, and so he grabbed the reviewed by tags. Again, all these tags, whether they're formal, the signed off by, the reviewed by, all well covered in submitting patches and the other documentation. Some of these, the signed off by has a very firm commitment as to what it means. It's well described what you're signing up to when you sign off by. The reviewed by is an informal tag, just showing that somebody has reviewed this thoroughly. And then he has a simple explanation again. Watchdog timer doesn't really need a novel in the commit log to explain it. And you see there's whenever you generate these patches, then now you have the per patch diff stat there. So you can see that modifies just the driver's watchdog, the new file, right? It's 399 lines, and then just the build plumbing, as I call it, that's the kconfig and make file. That's the only thing, self-contained patch, that belongs in there. So comments. So he got comments back, and he got a lot of comments back. And we missed things like choice of return, very common things that are missed. And Marcus took the time to do that thing, sort of the will fix thing. I will change that. There was a long thread behind this of multiple comments and how it should be done. In the end, he basically acknowledged them, so they knew that he was going to update the way they were suggesting. And so then he reposts, right? V2. And he had a billion things that changed, it seems like. And so he lists them there, goes through concisely of what's there, and makes it easy for the maintainer to see. Because with that many changes and you don't have the context, it made it easy for that Vim to realize that, okay, he took care of all those little things that was asked for. All right, and so there was more comments. We can see we got to V5 on this thing. And sometimes acceptance doesn't go exactly how you think it will. Marcus had a whole bunch of debug code in there. And because he had properly divided everything up in the series and he had the debug stuff as a separate patch, some helper things, Vim was able to apply the actual base driver, and he wanted to relook at the style of the debug stuff. So he comes back and says, hey, I've applied the whole thing. Had he wrapped all the debug stuff that wasn't an essential part of that driver all in the thing, this wouldn't have gone in that into that kernel. It would have had to wait another window because this was right at the end of the cycle. So that's a good testament to really divide things up, right? If there's a base driver, just submit the base driver, the simplest thing. Come back, incrementally add features, right? Don't try to do it all in one shot. And that's it for 201. That's like all the examples I could come up with. Did I generate any more questions? I know those are like really trivial examples, but it's hard to show really complicated in slideware.
So when you add a code or new feature you wanted to get upstreamed, what's the responsibility of also providing test cases to make sure that that code is covered and is verified?
You know, it really depends on the area. A lot of times a subsystem will have test cases. You take the DMA engine subsystem, at least for some portions of it, there's some test cases that already exist. The biggest thing is it varies from maintainer to maintainer is the end thing. Some of them are bigger on having test cases. There's definitely a move to have more of that as you submit things. Right now there's not a firm answer for, there's not a uniform answer for that. So, with something, I love to pick on Mark because I had to do a regulator driver a little while back, so we just keep picking on Mark, but he made a comment to me once that he says, well, you know what? It's your problem if your regulator driver is broken. It doesn't affect me. His attitude was, as long as it conformed, it was something that didn't break the build and everything, he doesn't have the hardware for it, right? And it follows all the APIs and the style that, for that piece of hardware, oh well, there's, they can only do, so much, right? So it really depends on the area.
Hello. I have a question about when I am ready for signing some patches, I mean a serial. I use a file under scribe get maintainers, and I will get many email addresses, but I don't know which one I should put which one I should to and which one I should CC. But I only know for the mail list I must put them to CC, but for others I cannot distinguish them, which one I should to and which one I should CC.
Okay, so I understand what you mean there, and that is a common problem. There's a bit of fuzzy logic that needs to be applied to what comes out of the get maintainer script. It's very, very verbose, as you know. So what it's doing is, one, it's parsing the maintainer's file, right? And that's very clear. The people you absolutely need on the to line, all right, or to address there are the ones that are listed as a maintainer, and it will tell you maintainer, right? And then that's the list, say for a subsystem or something. Then it will start parsing the git log, right? And look at the commit and see how many commits came from a certain person. Because you may have somebody that touched the same driver as you. Maybe you're fixing a bug, right? And it will suggest, if you start, sometimes the maintainer stuff is a little bit out of date. Maybe someone's doing a lot of work in a driver, and you kind of need to make a judgment call there that if somebody has, if there's an email that it pops out of that script that says XYZ person has had 80% of the commits in this file, right? Then it's probably a good idea to CC them so they see the change, because maybe they're doing some other work on there. They may want to comment on your work, okay? You may see something come out where it says, this person has had one commit against this file, and maybe it was 10 years ago, right? And it will go, find that. Probably not as important. You don't have to put everybody. Sometimes the list is huge, right? There could be 15, 20 people that have touched things over the years, and you just need to make a judgment call on what the output is. That if somebody's had a lot of changes, I think it's a good idea to add them in on the CC just to make them aware. It's kind of a balancing act to not put too many people on the CC line. Some people can get annoyed with that, and so yeah, you just need to make a judgment call there. Certainly, if there's a lot of commits from that person, then you would add them in. They
Okay.
probably would want to be aware. Yeah.
Okay, thank you.
Okay, more.
We was talking about sane mailers. Do you know sane mailer for Android?
Wait, I didn't quite understand that. Can you repeat?
Sane mail agent to send emails to mailing
Oh.
lists.
Email agent that's not insane.
That's
Yeah.
well, yeah.
For example, I
My
have.
opinion is Mutt is the only correct one, but yeah.
But right now I have some comments on my previous commit. If I want to answer, I have only my phone with me.
Well, yeah, K9 mail is probably the closest thing from there. I generally try not to reply from a mobile device.
Yeah, me too, but question is if we can some new development in this area, no?
Yeah,
Use SSH. SSH into
yeah,
mailbox.
Then I need to pull up. Then I need to open VPN to my company, and
Yeah.
so forth, and so on and so forth. It's troublesome.
Yeah, quite honestly, when I've had to make a quick reply from the tablet, it was exactly that, just SSH into my box and use MUT. So I don't like any of the clients on there. And Gmail certainly is no good. All right. Thank you very much for coming.